Hi class, it's Bill Berry here with a week 3 presentation on serialization. This isn't something that every teacher presents during this course. I find that it's a topic that's really useful and it saves us some time while we're working on our projects, and it's something kind of new and fun. It makes a lot of sense with some of the projects that we're doing, so why not introduce it to you. So let's jump in. We're going to look at how it works, what it is, write some code, and see it in action. So what is serialization? We have been taught, you have been taught in courses that you've seen before, how to write things to files. This is a different way to do that. It's a different way to make data persist between runs of the program. To persist means that when you stop the program, when you exit the program, and when you come back, you'd like to get the stuff back, right? So there are different ways you can do that. And so far, the ways that you have been taught in the past usually involve writing things to a text file. So writing things to a text file has certain disadvantages and advantages. The main disadvantage is you have to be very careful about how you do it. You've written projects like this, so you have to be very careful. What do I write to the file? Is it one per line? Is it everything together? Is it delimited? How do I have to break it apart when I get it back in? How do I recreate the arrays that it lives in? How do I know how many items there are? Do I have to write that, or do I have to write a loop? Like, you're just going to spend a lot of time figuring that stuff out. And while that's interesting and while it's useful and you have to learn that way, it turns out that's actually kind of a pain, right? Because you have a lot of thinking to do and a lot of work, and you'll spend a lot of your time just writing that process, right? Just writing that code and thinking about that process. For instance, in our student person teacher example, right, we have a lot of code in here to create students, create teachers, and show the stuff on the screen. That's great. But what if you needed to write all of this stuff to the file? Right? How are you going to decide how you're going to write the student data? How are you going to write the teacher data? How are you going to separate those? Right? All of that stuff is going to take some time and some thought. And yeah, like I said, it's kind of a pain, right? It's not any fun to do that. We would spend a lot of time working on that when we'd rather be working on logic and more interesting problems. So what exactly is serialization? It's a way to take an object and all of its entanglements, we'll talk about that in a minute, and turn it into a stream of bytes that can be stored in a file. You can do other things with it, but that's the main thing we're going to use it for, is take an object and convert it into bytes that can be written to a file. Now, the cool thing is, the super cool thing is, it could contain references. The object that you're talking about can have references to other objects. Those objects can have references to other objects, and so forth. You can have a big old model with a whole bunch of stuff with has-a relationships and is-a relationships and all other kinds of things. I would consider those entanglements, right? That's not a technical term, it's just my term to say everything's all bundled together. The beauty of serialization is that you can write the one object and all the other objects go for a ride, right? When you write an object, all of its has-a relationships go with it for the ride and all get written to disk. That is an amazing and quick thing, right? So you see why that might be a nice thing to have. And you don't really have to think about it, right? You just sort of do it and it magically works. Now, what do you have to do to make something serializable? It's not too hard. The first thing that you have to do is you have to make sure that every data type that's involved in that project is serializable. Now, what does that mean? Well, primitives are serializable by default, right? By their nature. So if you have ints and doubles and bytes and chars and booleans, they're all considered to be serializable by their nature. So you don't worry about that. The other classes, you have to check over to make sure that that is the case, that it's either primitives or it has to be marked serializable, right? We're going to talk about that. The main interface that we're talking about here is serializable. And remember that when you see able at the end, you're pretty clear it's an interface, and sure enough, this is an interface. So what you have to do is make sure that each class implements the serializable interface, and that any class that it has a relationship with is also marked serializable. Everything all the way down the chain, right? Everything has to be marked serializable. As long as you do that and you make sure that the classes are properly marked and they're using either primitives or other serializable objects, everything is super great. Right? It turns out not to be that big a price. The other thing that's interesting is that we have never seen yet an interface like Serializable that is what we'd call a tagging interface, which means it has no required methods. You just mark it, right? And the main thing that you want to think about when you mark these things is that you have checked them over to make sure that they are all primitives or that they have references to only other serializable objects. So that's the first thing you have to do is inspect all the objects that you're working with and make sure that they are serializable. So far, so good. So let's jump over and let's look at our code and see how we need to do that in our student, person, teacher example. Well, let's start at the top of the chain and let's look at person. So the first thing we're going to need to do here is say that this is going to implement serializable. Serializable, right? Now, notice that this will immediately compile, right? Now, let's see, it won't quite really compile. We have to import it, right? So import java.util. I believe that's in io.serializable. Right, okay, so now we control K. Notice that's it. All we had to do is say implement serializable and we have to import it. That's all we have to do. Now we have more responsibilities, right? Because we have to also look over this class and make sure that every single instance variable and any has-a relationships that we're carrying along with this when we go to write it are all already serializable. So we look here, string, string, string. Well, string is already serializable. If you want to look, go to the API reference, look up string, and then look up what interfaces it implements, and you'll see things like it implements comparable and it implements serializable. That means strings will know how to write themselves through serialization. You don't have to worry about that. If you looked up here and saw ints and doubles and floats and booleans, chars, bytes, all that good stuff, of course those are primitives. Those are already serializable. Now we look and see, are there any other things in here? Are there any other has-a relationships? Well, we're looking at this variables here. When we go to write this, that's really all that we're going to write is that stuff, right? We're just going to write those things. Does that make sense? So if you look down here, there's really nothing else that looks interesting. Like we're not writing the toString stuff. That's a runtime thing. That's really all that we're doing. Now we go out of here and now we think about student and teacher. Of course, we've changed the parent class. We've got to recompile. What about student and teacher? Do we have to mark them as implementing serializable? Well, no, they are already serializable because they extend person and person implements serializable. Therefore, student implements serializable. But we do have to inspect them and make sure that there's nothing that they've introduced that breaks the rule and that needs to be followed up on. Are there any other classes that they have has-a relationships with, especially here in their instance variables? Well, there's arrays. Well, arrays are by their nature serializable, no biggie. Here's an array of doubles. Doubles are fine, ints are fine. That all looks good, right? And there's nothing in here that we look at that looks like it should be problematic, right? Same thing in teacher. We can go look, but there is nothing there that's new, right? There's arrays, there's ints, no other kinds of interesting stuff. Yeah, they have a lot more data, but all that data is primitive or arrays. That stuff's all good, right? So that actually was pretty darn easy. All we had to do really is put implement serializable on person, check over a few things to make sure that we are careful, right? That's part of the reason that we do this. And then we have actually implemented this first part, which says make sure that everything in the class is serializable. So that's great. So now on we go. Let's talk about how you actually do the serialization. We have prepared for serialization. Let's see how we actually do the serialization. Next is, just like you'll remember that when you work with a file, there's usually a two-part deal to it, right? There's two parts. The first thing, let's say that you're opening a file and reading it with a scanner. First thing is that you get some sort of thing that deals with the file, right? You create a file object in that case. And then you hand that to the next step, which is the scanner, which will actually take over and read the stuff out of the file. So there's usually two things. There's something that's file-like as the first step, and then there's usually something else you hand it off to. And that is true however you're reading and writing files. That tends to be the general pattern that you have in Java. Same thing here. When you're trying to write to a file, you're going to first create a file output stream, and that looks remarkably like a file object, right? It's a string parameter with the name. So that is very much like a file. And then you're going to create an output object stream, and guess what you're going to pass it? That thing, right? The file output stream. And then you're going to do something that is magically easy, which is calling the write object method, right? So you're going to use this thing that you created here, this object, the object output stream, whatever object you create there, you're going to call write object, and you're going to pass the object as a parameter. And then when you're all done reading, you're going to close stuff up, right? You're going to close things. So let's go see how we're going to do that in our main code, right? All right, so we're going to come down here, and in this case we're printing things. I don't really know whether we need to print them, but fine, we have the code sitting in there, so let's just kind of move on and see what's going on. So I'm going to first do the serialization. Let us come down here. I'm going to put some blank lines, and then I'm going to start the serialization. So how do we do it? First, let me maybe put a little message so that I see on the screen that that's happening. Just so I can kind of watch the progress, because a lot of this is going to happen in the file system, and so we can look at the folder, but we won't see anything visually necessarily. So how do you have to do that? Well, as we talked about, you have to create a file output stream, and I'm going to call it file out. And I'm going to create a new file output stream. You see I forgot a thing there. People.ser. So I forgot this needs to be file output stream, and of course, guess what's going to happen? Cannot file symbol. Well, guess where that's going to be? That's going to be in import. Okay, and then guess what that's going to say? Hey, Java file not found exception. Does that sound familiar? Well, it sure sounds awfully familiar, right? So, of course, we have to take care of that. I'll choose to do that in a try-catch block, so let me go put that in real quick. So I started putting in the file, the try-catch, and then of course it says I've not seen file not found exception. So we got to do that. I got to go pull in this part. We're going to see that we have a lot of imports to do, right? And so then it says, hey, wait a minute. Let's see, file not found must be caught or delayed to be thrown. Okay, and of course what I need to do is I need to put this inside this, right? And I'll fix up all the indentation with the magic keystroke, and then we're good, right? So now we have done the try-catch to make sure that it's happy. We could also put a throws, and remember, of course, if you're writing supplier code, we wouldn't be printing, right? If we're working inside a class, unless we're able to print from that class, usually we don't. But in this case, we're writing main, so we're kind of okay. All right, so now we have gotten started. We have created our file output stream object. That's part one. Next thing that we have to do is we have to create our object input stream, and I'm going to call that something like out equals new object input, output stream, right? It's not input, it is output going this direction. And guess what we're going to pass it? We're going to pass it our file output stream, right? So we start a file output stream, and then we have an object output stream. Of course, it's never seen that. So again, I'm going to paste it there, and I'm going to do this, and I'm going to do this, and now it's happy, or is it happy? Well, now it's wanting us to catch an I/O exception. All right, so now we got to say, wow, now it's really complaining about lots of things. So we have a couple of options. I can put another catch here, right? I can put another catch and say, catch the other thing. Or another way to do that is that you can say this, right? You can put an or, and then you can, you can put the thing that it's complaining about, which is a I/O exception. I/O exception, right? Now, when you go to do that, this is going to say, of course, I/O exception. I've never seen that. Got to bring that in. You may wonder why I'm always doing them one at a time. A lot of corporate style guides say don't import star. Right? There can be bad things that can happen if you import star. You can get name collisions. Better to import just what you need. So now, of course, it's saying, it's something interesting. It's saying, hey, If you're going to OR these things, bitwise OR these things together, it doesn't make sense because this is a superclass anyway. IO exception is a superclass to file not found exception. So this is just telling us, hey, we can actually do this, right? That'll actually catch them both because that's a parent class. So in either way that we're working on this, an IO exception is fine. And in either thing, that thing's going to fail. Okay, so if it fails, we get that. Now we're ready to do the magic step, right? This is all the setup. We've marked the things for serialization. We've opened the file out. We have the file output stream and the object output stream, and now we can write. Now we have a couple of options here. Let's say that we are going to write out all of these people. We have this array. So one of the things that we could do is we could write each of these items one at a time. I could do something like this. Let me write a for each. For person, one person in college people. And then I could, oops, I got to put this guy, and then I got to come down here and say, then I could write using out.write object. Now notice that's a method on the object output stream. And I could say write object. And I could write college people that way. Oops, sorry, one person. Right? I could write them one by one to the file. If I were going to do that, I would probably start by writing the count, right? I would actually, we'll come back to that message in a minute, but I would probably .out.write object, and I would write the count of that, which would be college people length, right? I'm going to write that thing first because when I go back to read it, I want to read the count and then I can just read the objects. You're not worried about delimiters at that point. It's not your problem, right? It actually works beautifully. Just make sure you write the length and then you can write all the individual people and it works great. But are we thinking big enough, right? Are we thinking big enough here? If you can say to write one object and it writes all of its contents and entanglements and everything else that's interesting, why don't we just do this? Why don't we just write the whole darn array in one big splat, right? It'll write the array, it'll write the contents of the array, each of the array items, elements points to another object, each of those objects is serializable. Isn't that going to just do the whole thing? And the answer is it's absolutely going to do the whole thing, and it's kind of amazing, right? So I'm just for fun going to turn around then and I'm going to be a good citizen and I'm going to close that and I'm going to close this and then I'm going to see if there's any other complaints anywhere. What is it talking about? I've got too many things here, got too many closes. There we go. Okay, now one other thing it's going to say is, hey, when you write object, of course it has to know how to do that. Oops, what am I doing wrong? Output.write object. You can't do .write object. That would make sense. Okay, so now everything compiles. Look over that code, pause the video, and look at all of that a second. It's actually rather simple. I mean, it may seem like it took us a few lines of code to get there, but it's not all that more complicated than having a file object and then a print stream or a, some sort of other writing type mechanism. It's really not that much more complicated. And then you close the things, right? Close the inner thing and then the outer thing, and then it's good. So let us see first whether it works. And we're going to break this video into two pieces because it's getting a little long. But let's see if this magically did something. Now, I've just called this file people.ser. You don't have to call it anything you want. Put any extension you want. I don't want to put txt because this is not a text file, right? This is actually going to be a byte. This is going to be a binary file, right? So I'm not going to call it .txt because I don't really want people to see it. I don't want people to open it or touch it. It's something different, so give it whatever name you like. I just called it people.ser for serialized, but the extension doesn't mean anything. So I'm going to now compile everything and I'm going to run it, and if everything works as planned, serialization started. We forgot to put any other messages to ourselves, but let's go look at our folder and see if we see anything useful in there. People.ser. What if I were to open that in, say, Notepad++? What would I see? Well, there's the file. Notice it is a binary file. You can see some of the stuff in it, right? If you look around, you can see some of the stuff in it, but it's not a file that's meant to be modified by humans, right? It's not something that you're supposed to touch, but it is something that it did seem to write something there. So far we have done a good job understanding the basics of serialization. We still have to then talk about how to do the opposite thing, which is to get the things back. So in the next video, I'm going to go ahead and put this in here, and I'm going to say serialization ended. In the next video, we're going to take up the deserialization process. So that'll be a good one because we're going to zap the array in here. We're going to deserialize the contents of that file, which proves to us that everything can come back exactly as we left it. The other thing is we still have some follow-on topics, because what if you change these your software over time? Some of the files that you wrote in the past, do you still want to be able to read them in the future with new versions of your software? So there are some other little goodies, but that's the main quick start to serializing your data using these tools. So keep watching and pick up in the next one for the deserialization topic. Thanks.